Okay, so according to YouTube, I am live right now. I'm going to switch over to my camera. Hi there. Hope you're doing well. And I hope this thing is working because I'm using a new YouTube live stream mechanism that I've never used before to try this live stream thing. It tells me that it's live and that I've been live for 20 seconds. Hopefully that's the case. If not, then I guess I'll just be talking to myself. So I do have the chat open in case you want to chat. And yeah, happy Friday. Happy Friday. It is 2:58 p.m. here in Toronto, Ontario, Canada. It is quite cold, and one thing I have to do is I'm going to be sharing this link. I'm just going to check the link. Is this even working? Live? Yeah. Oh, cool. I hear myself. That's bad. Yeah, one final thing I need to do is I'm going to be sharing this with the WordPress design chat. There we go. Great. Now everything is shared. Everybody's happy. Hopefully folks can tune in. If not, perfectly fine. The reason why I do these YouTube things is because it's saved. YouTube automatically saves these videos. That way I don't have to. So yeah, welcome to the live stream. Today I'm going to be talking about UI animations. Animations is a very, very fun thing, very near and dear to my heart. All forms of animation, traditional, hand-drawn, web, game. And yeah, all the interesting thing is the principles from traditional hand-drawn animation and stuff totally apply to web, except you don't need to get so nitty-gritty. Web, you only need a couple of the principles from the hand-drawn traditional animation stuff, but it's useful to know. So hopefully this works. This is not working now. What happened? So what I'm doing is I'm going to share my iPad screen because I'm going to be drawing some stuff, none too fancy. And yeah, let me just get that set up. I had this thing set up and then something happened and now it doesn't work. That's fine. Cool. So my iPad is on my screen. I'm going to be sharing my desktop now. Desktop view. Yeah, you can see my iPad. Everything's great. You can also see my Chrome. That's fine. Can I move this up? No, I can't. Fine. You're just going to stay there, iPad. That's fine. What's going on? There we go. So what you're seeing right here is my drawing application. I'm using Procreate, and that is the app that I use to draw everything. I have had some people ask me what it is I use, and I use an app called Procreate. Wonderful application. Cool. Animations. So how animations work is, nope, I can't draw. It won't let me draw. Okay. Basically, you have a static thing, right? And then you want to move this static thing from here to here, right? So you have two static things. Animation is basically the movement of the thing from here to here, like so. That's animation. The end. That's basically it. But then we have to understand a couple of concepts. So inside of CSS, which is the main thing that you would use for web animation, not 100%, but the main starting point, CSS animation. There are two things that you would use within CSS animation or CSS transitions, which is another thing, to facilitate the movement for objects. So with CSS animations, they have something inside of CSS animations known as keyframes. I'm going to write this down. At key. Oh, this thing is making my writing. Hang on, give me a second. There we go. Keyframes. Yeah. And what a keyframe is it's basically the start and stop points between your animations. So a keyframe would be this, and another keyframe would be that. These are my keyframes. And the things in between, oh my goodness, please work with me. Okay, here's what I'm going to do. Okay, duplicate it. Come on. Yes. Duplicate it. Yes. All right. Those are not keyframes. This is what's known as the transition within the world of CSS, or for traditional animation, these are the tween. Tween. The reason why it's called tween is because it's in between. These are the in-between between your keyframes. That's it. This is all you kind of really need to know as far as animations for CSS and things. It seems relatively simple, which it is, but then these are some key concepts. Because when you write CSS animations, usually you only really focus on the transition for the most part. You have, I'm just going to delete all this now. Yep. Right. So you have a single component or something, right? And then it has two states. So let's say open and closed. So you have your open, and then no, let's not do that. Let's do small and big. Let's do small and big. It starts off small, like a modal or something, and then it grows to like a big modal. Yay! So you only really have the two states, and then you write your CSS to facilitate the transition. So in this case, it would be scale, right? Scale would be, say, 0.5, and then it'll scale to 1, growing from small to big. Hang on. All right, sorry. Cool. And which is fine, but it doesn't take care of all animation use cases. The other thing is, like I mentioned earlier, keyframes. Keyframes, it gives you a lot more finer grained control in terms of like how it is you need to control your guy from transitioning from here, the small guy, duplicate, the small guy to the big guy. Maybe you want to do some fancy things in between. I don't know. You can set up multiple keyframes, like keyframe, like let's say this is starting here. This is keyframe A or 0. Keyframe 20%, 40%, 80%, and then here's your 100. And what the percentages mean is it's basically the percentage of your entire duration of your animation. So you have a, whoops. All right, that's your animation. This is the entire length of your animation, the entire time. Yeah, duration. Yeah. Let's say this is 100 milliseconds or 1 second. This is your duration of your animation. The starting point is 0. The ending point is 100%. And these are your two starting keyframes, your two keyframes. You have keyframe 1 and 2. And if you have several keyframes in between, like so, I don't know what, I'm just eyeballing this. This is say 20. This is say 50. This is, I don't know, 65, 85, sure, whatever. So now you have 1, 2, 3, 4, 5, 6 keyframes where you said, hey, my object will move from here to here to here to here to here to here. And then how your object transitions from this to this to this to this to this is set up with your CSS transition properties. So yeah, that's basically keyframes and transitions. The other thing that's really handy to know about animations is how this movement even works. Because you have two static things. You have that, and then you have the big guy. You have keyframe, you have the starting state of keyframe A, and then B. How does this become this? We don't. So the underlying mechanism that allows for this to happen is there's a loop. There is a secret loop that happens inside of your browser that runs every time it needs to redraw something. And the frequency of that loop, I'm snapping, hopefully you can hear it. The frequency of that loop is around, I believe, 16.666 blah, blah, milliseconds. Where it gets that number from is we have 1 second, which is 1,000 milliseconds, and the desired frame rate we want for our UIs, our monitors, and so on is 60 frames a second. You might have heard people talk about this. So when you take 1,000 divided by 60, you get this number, 16.66666, whatever. So there's a loop. that runs every single time, every 16 point whatever milliseconds, that changes the initial, like this one. Oh, I need to animate this. I'm going to redraw it until I am finally here from A to B. So there's an animation loop that happens that transitions something from A to B. And that's how you get movement. That is the internal mechanism that works inside of browsers to magically move things within your UI. Do you need to leverage this when you create animations of any form? No, because this is nuts. That's why we use libraries in CSS, because they take care of this for us. Otherwise, you can definitely do it. But it's just a lot of headache that you would like to kind of not have to handle. I've built some of this stuff in the past, and it's definitely doable. Very nice to know, but not necessary in your everyday. So the trickiest thing when you're trying to animate something is, how is it that it transitions from A to B? When A becomes B, that is the trickiest thing. So with CSS, let's see if I can jump into the CodePen now. How do I close this? Click? I click it. Great, it works. Fine. Cool. So with CSS, I'm going to jump to my main camera because I'm just going to be talking for a bit. Does that work? No, here. So with CSS, it's tricky because you only have a little bit of information about the elements you have on the page. So for example, sometimes your UI might not have pixel values for heights and widths. So if you want to grow something from one size to another, let's say it's 50 by 50, and you want to grow it from 50 by 50 to say 250 to 250. Unless you know those numbers for sure, CSS won't be able to handle it. You'll need some JavaScript to add those numbers in. And let's see, what's another tricky thing about CSS? Yeah, so anything to do with sizes, anything to do with position, you oftentimes need JavaScript to kind of handle it. So for UIs like carousels or galleries, where you have, maybe I can jump back to my iPad. Does this work? Whoop. Is my iPad still connected? Hopefully it is. Yes? Yes? iPad? No? Oh, every time. Alright, I'm gonna... Whoops, I just made my canvas black. It's one of those days today, I think, where nothing is really working, and I just hit the microphone with my hat. This is great. This is great. Okay, how do I make this not black? Delete. What was I saying? CSS known values. Yeah, I think that's what I was talking about. I'm just gonna check the chat. Hopefully things are working. I don't know if things are working. Hopefully they are. If not, it's fine. Okay. So position. What was I saying? Oh yeah. Carousels and galleries. So here's how it typically works. So you have a gallery. You have a picture, right? And then it's one of those galleries that have that you're able to go left and right. These are more pictures. Let's pretend these are all pictures for a second. Picture. Alrighty. Lower the opacity here. So when you transition your gallery picture from one side, so let's say you want to go this one, and then you want to, I want to show this picture now. Something like this action, like this. The animation, how this works is it needs to calculate essentially the size of this, the size of this. So you need to know a couple of numbers. This is the size of this. Let's say this is X, this is Y. So now that you know those two sizes, you're able to then apply basically this number. We want to go, hey, thing, move yourself to the left to the value of the width of this picture because we want to show it. So move yourself that way, right? And depending on how you've coded this, sometimes you're not able to get this value, the Y value, just with CSS. You need some sort of JavaScript in order to like get that exact value, because sometimes it's like a random number. It could be 921. We don't know. We don't know until you calculate it. So that's why this is what I'm talking about, where you might not be able to do everything with CSS. You might need JavaScript in there to get value numbers in order for you to transition stuff. So now that we know that it's 912, we can now successfully move this thing 912 to the left, and that's how you get your gallery swipe kind of animation. And this is the first initial state, say this one. This is say A, and then when this one moves over, that's B, right? These are your two keyframes. How do we transition A to B? That's the transition stuff that we're talking about. And within transition, there are a couple of things we need to know. I'm just going to write this down. Oh my goodness. One of these days, I will have a smooth experience in using this thing, but it's fine. Transitions. So we have easing. Very important. We have duration. And then I think it was called properties. I might be wrong. Properties. So easing. Easing is how it moves from A to B. A to B. We have, if it's just a straightforward kind of thing, you have what's called a linear ease, meaning it'll just move. But then if you have some other alternative kind of easing, it might start off slow and then go fast, or start off fast and then go slow. So the type of easing you would use depends on the kind of interaction that you want to achieve, or what it is you want to communicate to the user. I will show a little bit more about easing in a little bit. The next one is I hit the mic again with my hat. I probably should take my hat off. Give me 1 second. There we go. So the other thing we need to know is duration. The duration is how long does the transition take from A to B? The time. That is the duration. And the properties. What will change? Is it the background color? Is it the width? Is it the height? Is it everything? Everything would be everything would be all. You can move. You can literally transition everything within the world of CSS and web. So yeah, those are the important things that we need to know. And now I'm going to close my iPad thing because if I touch it anymore, I think I'm going to break it. So I'm going to code something real fast here inside of this code sandbox thing. And what I'm going to do is I'm going to show some cases of easing and also some dynamic UI within the window on the right-hand side. So what do I need? Basically, what I'm going to do is I'm going to draw a circle that follows my mouse around. That's all I'm going to do. So let's do that. So what do we need? We need can I zoom in? Yeah, I can zoom in. We need a position, and we need some way to set that position. Equals use states, and that position, X is 0, Y is 0. Also, just want to say, when you're doing when you're doing your usual CSS-y kind of animation stuff, you don't need to do too much fiddling with this mathy kind of stuff. You might, if you're doing more advanced animations, like usually an animation library will take care of that for you, but sometimes you can't use it, or you might have access to one, in which case you might have to fiddle with numbers. Anywho, that's what I'm going to be doing now. I need React use effect, because we want the document to pay attention to my mouse movements. Okay, const, and then handle on mouse move, and we get an event, and from that event we get the page X, page Y from the event, which is the position of your mouse inside the browser. That's what that is, and we want to set the X and the Y with the page X and the page Y. Y is page Y. That's all that does. And now we're going to assign that function callback to any mouse movements we have in the document. So document add event listener mouse move. So anytime we move the mouse, we're gonna handle our mouse move thingy. And because we're good, we're going to unregister it. Document. This is a React thing, for a React hooky thing. If you want to keep your application performant, and so it's a good idea to unregister any events that you've bound to non-React objects, like what I'm doing. Right. So what have I done? Literally nothing. Oh, it's complaining because I wrote this wrong. I'm gonna do not disturb. Alrighty. So literally nothing is happening. You don't see anything happening. Why is this? Oh, because I didn't. There we go. I forgot. All right, cool. You don't see anything happening. That's fine. Console log. Here we can see that it's working. So if I console log the position, you can see that, hopefully you can see this number down here. Anytime I move my mouse, you'll see that update. That's because the X and the Y, the position of my mouse, is being updated every single time. And is that the case? Yes, it is. Whee! So this is the position of my mouse. Okay. And I just need to close the console. Please close. Close console, please. Oh my goodness. Close the console, please. Okay. It's fine. It's fine. In here we have a div. I'm going to draw the box now. We have a style, and then we have a position is fixed. The top is 0, left is 0, position top left, and then width is, I don't know, 50, height is 50, background, what color should we make it? Blue is fine. We're going to make a circle, so we need border radius is 50, and then we need to transform. Now we got to position the circle somewhere, so we can translate, and the value of that is position X, px, and then position Y, px. And this is going to work 100% first time guaranteed. Yay, we did. We have a circle that follows our mouse. So right now it's not in the middle of our mouse, but let me just, okay. That minus the half the width, which is 25, minus half the width, 25, and here we go. Now it's following my mouse. Yay. So what you're seeing right here, this is not really animation. This is just basically direct responsiveness to the thing that I'm doing. There's no animation yet. It's moving, yes, but it's corresponding to the direct actions of my mouse. We can start adding animations now. So this is an important thing to point out because I wouldn't consider this necessarily to be animation, even though it's moving. Just because it's not animation, I think, is something that you do when it transitions from like one state to another. This is like a direct, very, very, very immediate kind of UI update. Sort of like if you were to open like a drop down or something, and it just immediately shows. It just changes from one state to another. Animation is handling the state change, is handling the transition between A and B. So now we can add an animation to this. Transition. I'm going to do all 1 second linear. Alrighty. Okay. So now it's going to take 1 second for it to get from where it started to where it needs to end, like so. Like that. And you can see that it's moving in a straight line. Not straight line, it's a straight line. But the speed is the same. It's just constant speed. So here we have animation easing. CSS maybe? Usually these things are, I need charts. I need charts. Where are they? Great. So easing, this is the thing I talked about in terms of like how's the speed of which something transitions from A to B. You have all these various easing types. Not all of them are built into CSS. Ease in and out, ease in, those ones for sure. This ease in bounce thingy, this is definitely not a default CSS thing, although I think you can achieve something like that with Bezier curves. Another crazy thing. But yeah. All the various easing types. So if I were to change the easing type for this, where it transitions from A to be, right? I can change this to ease in. So it will start off slow and it goes really fast. Slow, fast, slow, fast. And you can reverse it by changing it ease out. So fast and then slow, fast and then slow. And you would pick the easing based on what it is you want to communicate to the user, or how drastic you want the animation to be, or how it is you want to handle that change. Because for things like dialogue boxes and modals and all that kind of stuff, it's very disruptive, right? Where you're going about your way, and then all of a sudden, boom, a box pops up in your face. And not only does a box pop up, but typically there is like a background that exists, right? It mutes the background a little bit, and a box pops up, and boom, in your face. So easing is there to help bring that in a little bit more of a subtle way. So let's just check out Bootstrap's modal for a second. Does this work live? Yeah. So there's 2 bits of animation going on right now. Hopefully you can see this. So the background, the gray, the transparent black, whatever it is you want to call it, the overlay is coming in. The opacity is changing from 0 to whatever this is. So it's starting the animation process. It's getting the user like aware that, oh, it's anticipation. Something's about to happen. Something's about to change. Once this is like kind of 50% in its cycle, the modal drops down. So the modal dropping down indicates like where it is the modal is coming from. It's coming from the top. So that this 2-step process is useful and very handy in preparing the user like to that. Hey, something is happening. It's fine. And the thing that's changing is this box that's coming from the very top. So these very little subtle details really help handle the disruptiveness of this interaction. So yeah, and you can break out. So there's 2 moving pieces here. One is the overlay, one is the box coming in. And I'm not 100% sure what kind of easing they're using, but most likely it's like a linear ease or just an ease in, ease out. I'm not too sure, but usually is one of those. So already you're starting to see two different something that's a little bit different here. You're seeing 2 objects being animated in, but at different times. So inside of animation, web animation, this is often known as staggering. Does this work? Yeah, cool. Staggering is basically, here you can see that not all the reds change at once, or not all the blues change at once. There's a little delay between each one that helps sell the illusion that like all this is kind of moving together in one fluid movement. Otherwise, you just have a kind of like a sharp change. So staggering is like a technique that you can apply for animation. Very useful when usually you see it when there's a list of things. So you see the list of articles, list of photos, list of some things just kind of loading in slowly like one after the other. It gives a very nice effect, but it also helps sell the relationship between all these little items and how it and it sells the movement and makes things feel a lot more cohesive and a lot more I don't know, it's just nice. That's one way to put it. It's just nice, especially here you can see the transition from one to the other, from the red to blue as it staggers out and staggers in. Yeah, it's a very nice effect. Staggering is another key little thing with animations, usually applied to lists or when you're trying to coordinate multiple things to animate together. You can stagger them. Why did I have this one up? So this is an example from a library called React Spring. And I believe the original implementation of this kind of example came from Framer. And there is a very, very interesting, very hard thing that's happening here. This is not something that you can do with CSS. That you need a JavaScript something in order to handle this. And you can see right here, it's a very nice effect, right? You move this around, this orange box is following my mouse because I'm holding my mouse down and moving this around. Again, that's not necessarily animation because it's immediate feedback. But the thing that's animating is the items underneath that magically know how to make their way into the position that they need to be in. So remember earlier, I talked about that cycle, that 16 millisecond cycle that fires, right? Inside of JavaScript, you have access to that. It's called request animation frame. That's basically the browser exposing this cycle that happens every 16 milliseconds. And you're able to do something. You're able to tap into that to do something. And how this library works underneath the hood, and this is why it's really complex, is there is a cycle, that 16 millisecond cycle is happening. Every single 16 milliseconds, it checks where, well, it needs to know where the current item is that you're holding, which is the orange box. It needs to know the position of it. That's the, I'm going to try to draw a box. The X, meaning how far is it away from the left edge, the Y, how far it is from the top edge, and also its own kind of sizing, so it knows where the center is and so on. So it needs to know that. It calculates that every 60 milliseconds. In addition to that, it needs to check where it is in relation to the list. That way it'll know that, oh, if it's gone beyond a certain threshold, like around halfway for the next item, then the item that it's hovering over needs to then transition to where it was before. Okay? And all that math, all those calculations happen every 16 milliseconds. And that is how you get UI like this. Very complex stuff. And again, that's why you use a library to take care of this for you. Right. Here's my guy. So let me just check the chat to see what's going on. Cool. Hey, Michael, I see you chatting about stuff. Unless you're rotating a tire, you don't need math unless you're doing some other stuff. Context awareness is tricky with CSS. Yeah, that is the thing. Like, have you ever tried, like, a very simple example of something that you think you'd be able to animate with CSS but you can't really, is an accordion. Let me see if I can find that example in Bootstrap. They had it before, unless they got rid of it. Right. So you would think that you'd be able to animate this inside of CSS, right? Like the collapsing of a thing and the growing of a thing. You know, just height 0%, height 100%, right? But that's where it gets really tricky, because 100% of what? Of the box of itself. Like, usually for folks who have done like widths and heights 100% and stuff like that, you'll notice that sometimes it doesn't work. Sometimes you need the most parentist object to have a height of some kind. So you could have, say, height 100 VH, 100% was it viewport height? When you have something like that, the browser knows the height of the thing. It has a number. And then based on that number, it'll then use that to calculate the heights of all the nested little guys. But usually with CSS, when you have heights like 100%, or when you don't have a pixel height, you can't use it to transition, because it doesn't know how to get, it doesn't know what A is, it doesn't know what B is. So that's why you need, so for this one, I know underneath the hood, Bootstrap uses JavaScript to calculate A and B in order to transition the height from A to B. And hopefully we can see something here when it changes. Does it work? That was very, very fast. Pay attention to this little guy. I'm going to see if I can make it bigger. All right. For a brief second, the height was 280. And the reason why it was briefly 280 was they needed a number to transition from A to B. Otherwise, they don't know what B is. So, yeah. Height awareness accordions. Yeah. Yeah, that's all this stuff is. It's nuts. And there's another little detail. There are basically life cycles when inside of animation. So you have the start and then you have the end, right? I'm starting here and I'm ending here. And then you have the tween with the in-between. So usually with animation libraries or anything like that, you have lifecycle hooks. So you have the pre-start, and then you have the started, and then you have your transitioning, and then you have the before, end, and then after end, or you can call this complete or whatever it is you want. So you have all of those little hooks. That way, it's useful to coordinate animations. Maybe you need something to start in the middle of another animation. This is very useful for like doing something when an animation finishes, or maybe before something starts. I know, let's say, a very popular animation library, Anime.js, they provide callback hooks in between their cycles. And yeah, staggering. And this is very, like, it's so nice, but it's so complex underneath the hood. And again, you don't really need to do a lot of complex stuff, especially if you're just doing like drop downs and modals and things like that. You really need to do complex stuff when you're doing something like this. UI is like this. Woof. Woof. Very nice. But geez, based on what I've demonstrated earlier, when I said 60 millisecond math every single whatever, and then calculating all that stuff, you can imagine how much it takes to do something like this. It's pretty nuts. And again, that is why you use a library. So when should you, now that we know all the various mechanics and principles when it comes to animation, when should you use it? Ultimately, within the world of web and UI, animation, the purpose of animation is this. That's all you're trying to do. You're trying to communicate to the user that something is happening. So modals are a good example. The modal is probably the best example when it comes to component-based UI animation, because something dramatic is changing in front of their in their user interface. You need to soften that blow somehow, and you also need to give some anticipation of where this box is coming from. Modals are a great example. Another great example would be nav menus. Like you see inside of a lot of the more Google material kind of applications, you have nav menus that kind of slide in from the left and the right. You can definitely just snap the menu in. It's not a problem. But sliding in that menu, it lets the user know that, hey, this thing is coming from somewhere. So when the menu closes, like, you know where that menu is coming from. And also, if the menu is associated with, say, a hamburger icon or something similar to that, then they will know after they've experienced something like that. They'll know where it is to look for when they need to interact with that menu. So animations, in addition to communicating where something is happening, you can also teach the user certain interaction patterns that you will like within your application. Where, like, a really tricky gray area, I think, would be drop-downs. So the reason for that is, for sure, you can transition this box coming down, and libraries, I think, like Material UI and various other ones, they do that. But here's where it's tricky. You don't want animations to get in the way of a user doing something. And the reason why drop-downs are tricky is because if the drop-down is slower than them like going to that area, it makes your app feel laggy. And that's because, like, you're preventing them from doing something faster. Drop-downs should, in my opinion, load as fast as possible. I guess I can try to inspect element and hack this speed in there, but like, I don't know if you can recall a time, but the next time you interact with a dropdown and it kind of feels a little bit laggy, most likely it's because of an animation in there getting in the way. You don't ever want animations to get in the way. You want it's there for communication. It's there to help with the experience. It shouldn't hinder productivity. That's not what an animation is for. That reminds me of the time that Windows Phone came out originally. So Windows Phone, there was a lot of animation within Windows Phone OS, or I don't know what they called it. But the reason why they needed a lot of animation when it transitioned from like one page to another, you had tiles kind of like going like this or whatever it is. The reason why they did that was because the operating system or the phone didn't have enough RAM. So to mask the slowness of the phone, they added really nice animations to transition from one to the other, which is very clever. It's a very clever workaround. It made the user experience feel really nice, but it was a workaround. It wasn't like an intentional thing. Let me see what Michael is saying. I love that you're here, Michael. Either it's an animation. So what he says, yeah, any navigation/form control should load as fast as possible. I agree. JS dropdowns drive me crazy. I know, man. I know. Either it's an animation in the way, or the navigation is waiting on a conditional to show and hide something before it renders, as I end up clicking the wrong thing. Yep, that happens way too often. And dropdowns are notorious for experiencing that. And I think tooltips and popovers as well. Not as much, actually. I sometimes, let's see. Yeah, there is a little opacity thing happening here, but it's not that bad. For some reason, dropdowns are the thing that like really get in the way if you add animations in there. Just because I think when you click on that UI, you know that there are options there. The user already knows that actions are going to be there for them to click. And if they've used that UI a lot already, then they know exactly where it is they need to position the mouse. So let's pretend this is some sort of... No, I'm going to jump to the drop-down example. Here. Something else here, right? So let's pretend I'm using your application. I'm very familiar with the UI. So, and I've done this action, let's say, 20 times today. So I already know where it is I'm supposed to position my mouse the moment I clicked for this to open. But if there is some animation that gets in the way of doing that, the app feels laggy. So that's the best example that I can think of. Speaking of laggy, it's animation and performance is like it's a tricky thing to kind of get right. I can't remember who it was that created this. I think it was either Paul Irish or Paul Lewis. CSS animation paint. Paint. CSS performance animations. There was a site that showed you which specific CSS properties you can animate that will paint or won't paint. So what am I talking about when I'm saying painting? Okay. Alrighty. So firing up Chrome and firing up your developer tools. Oh my goodness. There we go. Rendering. Paint flashing. Yeah. Where else? Layers and borders. Yeah, cool. Alrighty. Paint flashing. So what is paint? Paint is a thing that paint happens when your browser needs to redraw something on your screen. It's repainting a little section or whatever inside of your screen. And it's a very expensive process as far as browser rendering goes. And you want to limit that as much as possible. So right now, there aren't a lot of green flashing. That's happening on my screen. Let me just adjust this animation here. Oh no, don't do that. Save. Okay. It's happening a little bit, but it's not that bad. And the reason why it's not that bad is because it's leveraging transform in order to change certain things. So earlier I mentioned that there are certain CSS properties that play well with the browser paint and certain ones that don't. The ones that play well, I need to find a site somewhere, are basically these ones. Scaling, anything to do with transforms and opacity. So the reason why is those particular properties, the browser is already aware of the size and the location and the shape of the thing. It's already computed and calculated all that math, all those numbers. So the next time you need to change it, it's just kind of manipulating or moving or shifting that thing in that layer. It doesn't need to do full-on calculation again. But other properties like width and height or position, top and left and whatever, those ones require the browser to do another scan of everything in order to figure out those numbers. So the more you animate using those specific properties, the more expensive the thing becomes. And the more expensive the thing becomes, the more processes, like browser processes and all that kind of stuff that need to happen, which may result in laggy UI. Because remember that 16 millisecond cycle that happens, the browser might not be able to get the animation in there for the 16 millisecond iteration. And when it doesn't happen in that cycle, if it misses a frame or misses whatever, that's when your frame rate drops from 60 to like 40 or something like that. And anytime that frame rate drops, you visibly see lag, and that's how all that stuff works. So let me see if I can try to introduce lag somehow. So instead of doing transform, we will change this. No, top is Y. I always get those mixed up. Position Y, X and Y. Does this? All right. So it's not that bad. Not that bad. I need to find a different example. I'm gonna do something funky. Position, width and Y. Every single time, X and Y, left and right, top, whatever. I gotta draw a box, or else I can't figure it out. Position, height is Y, width is X. Okay. Yeah. I did not expect this, but this is great. So, let's do something else. I want the height to be 100%. That way it's always a square. I'm going to get rid of this. So now I'm going to draw a square. I think. Nope. I need to figure this out. Height is 0. Here we go. Math. Padding top is 100%. The height is actually 0. And now I get a square. Guaranteed. Nope. That is wrong. What am I doing wrong? I swear. This is how you're supposed to figure things out. It's fine. Padding top, it's background. I'm going to get rid of background. There we go. Wait a second. I want to be able to RGBA 0, 200, 0, 0.5, I guess. I want to be able to see the green flashes. There we go. Is my thing green to begin with? Yes, it is. I can't have it green. Oh my goodness. This demo is going great, guys. Okay. Well, hopefully you can see this on the screen. So because I'm transitioning the width property right here, every pixel that it moves, it needs to do a calculation of the width in order to redraw it, to repaint it. So sometimes transitioning things like widths and heights is unavoidable. Like for the case of accordions, you have to change the width. Sometimes it's not. Sometimes you can work around that. So in this case, you can work around that by leveraging a transform. The transform is transform translate x y x x z, no scale x scale x scale x is oh man, math. Well, basically, I need a percentage number, 0 to 1. And that size is the width of the browser. So now it is the width of the browser divided by position x. X position. Nope. All this is wrong. Okay, here we go. Okay. Performance transforms. Am I right? Oh my goodness. Alrighty. It is position x divided by window inner width, and that gives you a number. And that can be applied to the scale transform, but something's not happy. I think that's it. There we go. Close enough. Close enough. Oh man, it is not happy at all. Jeez. Yeah, sometimes you try to make something more performant and ends up not being as performant. So yeah, so this is an example of something dramatically repainting, and it's just becoming really, really awful. Which is ironic because I tried to make it not awful. So in your journey in trying to make CSS performant, animations more performant, it's a good idea to pull up Chrome, pull up this paint flashing thing, and see whatever it is the heck you're doing. How bad is it? So if it's doing something like this, it's pretty bad. Just because it's recalculating so many times in order for it to redraw. And you can see this when you run a performance test. Performance test. All right. Okay, do this for a little bit. Wow, this is the first time I've actually seen this inside of dark mode Chrome. I haven't ever done this test before inside when I had Chrome in dark mode. I kind of don't know how to look at this just because all the colors are different. Anywho, GPU. Oh man, I'm kind of tempted to just turn this thing from dark mode to not dark mode because I really don't understand how to look at this. This is awful. Anywho, the things at the top, these are your frames per second essentially. You want it all to stay relatively high. And anytime that there's a dip like that, that means you've dropped some frames, which I mean, the thing I'm doing right now is very, very simple. But if your application is heavier, it's something that you can see. And sometimes, depending on how it is your JavaScript is computing this stuff, it can actually block functionality. So, like let's say you need to load some data or you need to like render something on the screen. If your animations are taking a long time, that loading of the thing, you might actually have to wait until your animations are done, which is bad. So yeah, using these tools like checking paint flashing, doing some performance profile checking, it's useful to see where is it that your animation is bad in terms of performance. How can you refine it? How can you tweak it? Can you use alternate CSS properties? Can you leverage a library to handle this for you? Can you just remove the animation entirely? You don't really need to do this until your application or your experience gets a little bit bigger, when it's a little bit more substantial and you have quite a few things going on. If you're aware of certain properties, like best practices and so on, then this could just be part of your workflow. I know this is certainly mine. When I do anything animation related, I always check this stuff, just because like the earlier you can just like take care of these problems, the less likely it'll just explode later on when you need to build something bigger, or where you have larger pieces animating or something like that. So yeah, animation performance. It's fun. It's also challenging. It's also very hard. And if you're like me, seeing this profile thing in dark mode for the first time, it's very confusing. Let me just check the chat. Cool. Michael's there doing his thing. Cool. Hey, Michael. So yeah, that's animation inside the context of web. I apologize if this was kind of all over the place. I really need to have some sort of like plan, like outline. This is what we're going to be talking about today in these specific sequences. But yeah, so to summarize, I think I went over animation principles, kinda, CSS animations, transitions, keyframes, how that works, tweening, in between all that kind of stuff, the animation loop, the thing that fires every 16 milliseconds, because that's how you achieve 60 frames a second. And within the browser, we also went over, I guess, static versus dynamic calculation. So things where you can transition very comfortably with CSS, and some things you can't use it for. So the things you can't use it for are values that you don't know of yet. So the position of your mouse, the height of something. You need JavaScript to just do a really fast kind of calculation. That's another different type of animation. And to basically, when you're doing anything complex, just use a library, because they've taken care of all that stuff for you. All the math, the cycle, the render, whatever, the callbacks, they've taken care of for you. Just use the library if you can. And performance. So animation performance is like, it's a real pain if things are starting to slow down. So fire up your Chrome DevTools, do some performance profile checking, check for paints, and check your little, I'm not sharing my screen. So check where your frames are dipping and see if you can do something in there. It could be a CSS thing, or it could be a JavaScript something, just like blocking your animation. That can happen sometimes. And I think I'm going to conclude with one more thing. This has a little bit to do with implementation, kind of. Implementation details. That is the flip principle. Flip. CSS flip animation. Not flipping cards. That's not what I'm talking about. I need performance. Arrow twist. Yeah. My man. Flip. So what does flip stand for? First, last, invert, play. What does that mean? So, dang it, I wish I can draw. Can I draw? I gotta fire up my iPad thingy again. But this is important. Come on. Screen mirror. Yeah, there we go. And I gotta enter my secret code. Where's my secret code? Huh? Hey, give me my secret code. There we go. Secret code. Okay. All right, go away. There we go. Flip. Okay. What is flip? Flip. It is an animation technique where you have hang on. I need to draw this. And then I need to draw, I'll keep it here, but I'll draw it 50%. Okay. You're starting F first. This is your first. This is where you start. Keyframe 1, right? And then last, where does this square, this happy little square, where does it need to go? It needs to go here, right? This is your last. This is your keyframe 2. So we have keyframe 2, we have keyframe 1. So now we know where it is we're starting. We know where it is we're ending, right? So we need to know, in this case, what are we changing? We're changing the width and the height and also the position. So we need to know the x, y. We need to know the y value. We need to know the x value. We also need to know the width, height, and also for this guy, we need to know the y for here. We need to know the x for here. We need to know the width. We need to know the height. Okay, so now we know our first, now we know our last. Now we need to inverse it, meaning, what is the difference between this width and this width? So you do math for that, the difference of that. What is the difference? I got these reversed, width and height. You know what I mean. Comparing height to height, width to width, y to y, x to x. What are the differences between all of them? All right, so now you have your diffs. Now you have the inverse. The last bit is play, P for play. What that means is, you know where you're starting, you know where you're ending, and you know the values that you need to apply in order to transition from here to here. So you plug that in via, in this case, you would leverage some CSS transitions or something. So you're starting with, say, a width of 50, and you want to transition it to a width of 250. You plug in all those numbers, and then you trigger the animation somehow. Usually it could be, again, with a request animation frame, that could be your trigger, or you add all these things to like a style sheet, a CSS class, and you apply it on. Some sort of triggering mechanism to hit play. And when you play, it's able to transition between the start to the end using the diffs as the value. And that is how you do a performance animation using the flip principle. And a lot of libraries have leveraged this thing in order to do their stuff. So this is a really good one. This is how they do it underneath the hood. And if you've used libraries like Isotope, I believe that's it. Nope, Isotope.js. There we go. And it does something like this. Right? So every single time it changes, it needs to calculate where a square is, where its starting position is, and where it needs to go. And then it'll fill in the gaps using the diff, the inverse math. And it applies to every single square. And that is how you get a transition that looks very fabulous, like so. But yeah, those are the little hidden mechanics of how something like this works and how you can achieve very nice, very fluid CSS animation beyond what you get with straight up CSS. You need some JavaScript in there to do some math. And oh boy, like we've learned today, there's lots and lots of math involved in getting something like this done. Anywho, yeah, ending on the flip principle, which I think is very important. And thank you so much for tuning in. And I hope you have a fantastic day and a fantastic weekend. Catch you later. Bye. Ending the stream. Stop.